Hello, everyone. I'll give a couple of minutes while everyone comes in. But thank you for being here. My name is Isabella. I work with marketing here at TATSoft, and I'm really happy um, to have this online session, a very special Technical Tuesday. We're going to be talking about AI on the plant floor, especially machine learning and how frameworks fits into that. So feel free to drop a hi on chat. Should be open to everyone. Um, Yeah, like I said, I'll give a couple of minutes, but I'll just get started kind of introducing how it's going to work today. Um, we are going to go through our presentation. We're going to show a little bit of a demo, and I have it here. We're going to talk a little bit about the platform, TATSoft and frameworks for those who don't know us. We're talking about machine learning, why it's becoming so practical and important in industrial systems. We're going to talk about ML.NET specifically and why that is important. Eduardo is going to show us a little bit of a demo around that. And finally, we're going to take a quick look at MCP, how that works. We are going to have some time for dedicated Q&A at the end. But if you guys have any questions in the meanwhile, please drop them on chat. We'll answer them if we can. If not, at the end, we'll go through them. It's no problem at all. So the session is being recorded, so I will be sending that to you guys after the presentation. All the resources the guys mentioned as well, so like different examples and tutorials that they might mention. Don't worry, I got you. I will be sending those as well. Too. So just real quick, who do we have here? Really happy to have my team here. So Dave Hallier is our VP of Business Development. Eduardo is our automation engineer. Like I mentioned, I'm Isabella. And we got Scott Gray, who is our senior solutions consultant. Thank you so much for being here, guys. Looking forward to this presentation. And yeah, it's going to be great. So let's get started. Let's talk a little bit about TATSoft and framework. So Dave, don't you want to introduce us?
Sure. So, for those of you who haven't met us before, TatSoft has over 30 years of experience building industrial real-time software. The company was founded by the original creators of InduSoft, and that experience shaped our focus on OEMs, embedded systems, large-scale industrial deployments, and so forth. Today, TADSoft operates globally with teams in the US, Brazil, Europe, and Asia, and FrameworX is used across industries like manufacturing, engineering, water, wastewater, food and beverage, life sciences, transportation, oil and gas, and data centers. Um, FrameworX is our modern SCADA and IoT platform built on .NET managed architecture with native support for Python 3. A key point is that FrameworX is a single unified platform, not a collection of add-ons, alarms, historians, security scripting, MQTT broker, Sparkplug-B client, edge connectivity, plus over 100 device connectors and visualization, all live inside the same designer in runtime. You configure everything in one environment and deploy it on the same project across edge devices, servers, virtual machines, or containers without rewriting the application. That unified foundation is what makes advanced capabilities like machine learning practical. So FrameworX is built on .NET to provide a modern managed runtime with performance debugging, versioning, and long-term support. Practically, it means the same language and runtime are used for scripts, calculations, alarms, business logics, and for today's topic, machine learning, without bolting on separate execution environment just to do AI. This leads us directly into why we're talking about machine learning.net inside frameworks. We recently held a training class, and we emphasized that machine learning becomes much harder when it sits outside the operational environment. External machine learning often creates gaps, duplicated data, fragile integrations, and limited operational visibility. By running ML.NET inside the same platform that already manages tags, alarms, historians, visualization, all that, machine learning results become first class operational data that can be alarmed, logged, visualized, and otherwise acted on like any other signal. That's the foundation for everything we'll show today. With that context in place, I'd like to introduce you to Scott Gray, who will talk about why machine learning is relevant in industrial applications. Scott, take it away.
Thanks, Dave.
Let's go.
So, why would you use machine learning? The most obvious application for it is to optimize your process and improve outcomes. That's pretty straightforward as to why you would want that. Another reason is to retain expertise. You can capture knowledge. You might have a maintenance person who understands a machine and knows what's wrong with it when it fails, or an operator that knows exactly what set points or values to set to get a good product. And by using machine learning, you can retain that. You don't have to worry about those people walking out the door or the proverbial being hit by a bus. And also, even if you have those people in your organization that can, have that kind of knowledge, they tend to be specific to where they're working. And machine learning can take that knowledge and spread it across your entire process or your whole plant. Next. Okay, so these are some examples of how specifically machine learning can improve your process. So you can increase production output, you can reduce scrap and the amount of reworking that you have to do. You can shorten cycle times, which, especially in high volume discrete manufacturing, getting portions of a second per part can be a very big deal. You can reduce unplanned downtime, improve product quality. Energy savings is a very big part of industry right now and very important to a lot of people. You can do better scheduling and root cause analysis. I worked in tier one automotive for a while, excuse me, and the quality people are, whenever there's a quality issue, they're always talking about doing a root cause analysis so that you can make sure that that same, quality issue doesn't occur again in the future. So these are some examples of where there's the best return on investment. Predictive maintenance. You always want to perform maintenance on a machine or on a pump or a motor when you schedule for it, not during runtime. And of course, whenever a production is down, it can be very expensive very quickly. Process optimization. Again, increasing the amount of product that you get in a set amount of time can increase revenue. Defect detection. If you do ship bad product to a customer, the repercussions of that can be very, very costly. Things like having to do 100% inspection and having to do a lot of reports that take time and money. And you can increase your scheduling, which again, if you forecast better, you can produce more better parts. Next. So these are examples of actual machine language or learning models and an example of how you would use them. So binary classification is when you predict one of two different conditions. So an example of that would be fail or not fail. Multi-class classification is where you have you predict one of many different conditions. So if you have parts that have quality defects, you can classify them. That's important because if you keep having one type of quality issue or defect, you can root cause analysis, do one, and find out like maybe what's causing it. Regression is where you predict a numeric value. So you can estimate things like a cycle time or what your energy consumption will be. Time series forecasting is where you predict future values in a sequence. So you can forecast hourly production output. Anomaly detection is when you identify unusual data that deviates from the norm. So again, if you have abnormal vibration or temperature, that might be indicative of something like a motor or a pump failing. Clustering is where you group data into clusters based on similarity. Um, that allows you to sort of understand what state you're in, whether you're in a normal state, a stressed state where that indicates that maybe you're going to have a failure, or an inefficient state, meaning that there's a window of opportunity for improvement. Decision trees, that's where you make predictions by splitting data into branches, and the leaves are actually classes or numeric values. So you can look at what variables drive failures. And gradient boosted trees is where you build trees sequentially, where each tree corrects the errors from the prior tree. So in that case, you can look at complex relationships and improve productivity. Next. An important concept with machine learning is you shouldn't use it to try and control your process. You leave the PLCs and the controllers and the way that traditionally you control a process in place. The machine learning allows you to analyze data and make better decisions. So ML.NET, that's the Microsoft machine learning libraries. So when would you use it? Typically when you're using ML.NET, the data that you're using is structured. So things like a temperature, a vibration, a pressure. One of the advantages of using ML.NET is it's very fast because it creates C# or F#, but we only use the C# code, and that's compiled, so it runs very fast. The other advantage of using ML.NET is, as Dave mentioned, FrameworX is based on .NET, so ML.NET and FrameworX are both .NET, so you have a fully integrated environment. And for the model building, you can just write code where you call ML.NET methods from within your code that you write manually. But within Visual Studio, there's an extension called Model Builder, and it's actually a wizard that it sends you through that at the end you have a window where it creates code for you, and you can cut and paste that right into FrameworX. Next. That's a screen grab of the model builder in Visual Studio. So you can see that the steps at the left there, scenario, data. Scenario is where you select what ML model you're going to use. Then where you're getting your data, you can train the model, evaluate it, and then generate the code. We actually recommend that you train and evaluate your ML.NET models in Visual Studio. And once you're happy with them, that's when you cut and paste it and run it in FrameworX. We're not just limited to ML.NET, though. Python's been around for many, many years, and computer scientists that first started doing machine learning, for whatever reason, they chose Python. So Python's been doing machine learning for many, many years. So why would you use Python instead of ML.NET? Well, typically the data you would use in a Python-based machine learning would be much more complex or time series data. The downside is that it runs a lot slower because Python is an interpreted language as opposed to being compiled. So it can run literally 10 times slower than C#. The integration, again, you're going to write all your Python code. I'm not aware that there's a Python model builder like there is in ML.NET, so you probably are going to be writing all that code from scratch, but there's extensive libraries for doing machine learning in the Python world. Next. So the key is to choose the right tool for the job. When would you use ML.NET? Well, certainly when speed matters. So an example would be things are happening in the process in real time, and you want to react to those. You're going to have better results using ML.NET because it runs so much faster, as I mentioned, about 10 times faster. There's tight integration with .NET. Again, as Dave said, FrameworX is .NET, ML.NET is .NET. So there's a lot of interoperability between FrameworX and ML.NET. And of course, it's a good way to get started. You pick a process that needs that real-time reaction. And then you can use the model builder, which makes creating all that machine learning code very simple. When to use Python? Well, there's a much richer ecosystem of libraries. There's PyTorch and TensorFlow and JAX and all these well-established libraries that are open source on the internet. Typically, you would use Python for more deep learning and using neural networks. And you would do it as an offline analysis. So that would be for like planning purposes and things like that, as opposed to reacting to real-time events and during the process. So that's my part.
So yeah, thank you, Scott. That was great. I think that gives a good intro into machine learning in general. Like Scott said, there's different ways of implementing it. ML.NET is just one of them. And that's the one we're going to dive a little bit into. So Eduardo, take it away. Do you?
Thank you. I just requested for share screen,
Yes,
please.
I did.
So what I'm going to talk you today is about the ML.NET. We'll do a demonstration here and also about MCP.
Ah,
So I'll start by the ML.NET, how that runs in frameworks. So can you see my screen?
not yet. Do you mind trying to share again?
Okay.
I think I might need to stop sharing as well. Stop
Okay, you
sharing.
should be able to see that.
Yep, there you go. I see. So go ahead.
Okay, so this is a framework solution and it implements some of the tasks that Scott was talking about, regression, binary classification, and anomaly detection. This is done, this is a frameworks screen. We did is a simple one. We just have some grids, some symbols. And what we want to show you here is that here in the first regression example, we had a bunch of data containing three columns: pressure, temperature, and quality. And the quality is the result of the pressure and temperature. So what we did was to train the model, the machine learning model, and now we have current data being collected from the field. In our case, it's simulated, of course, but what it does is to predict the quality. So every time the pressure and the temperature changes, it's reading from the field. We run the machine learning model and we predict the quality. The same happens to the binary classification. So we have a lot of process variables, and then we predict the pass quality control. When it says one, it's because it passed. When it says zero, it did not. And we also have a visual representation here. When it's red, it's because it did not work, and green is good. Then we also have the anomaly detection, which has a lot of process variables, and it says if this is a normal state or not abnormal. And yeah, the purpose of each task in machine model is different. I always recommend you to talk a little bit with any LLM to know what's the best one for your specific case. And in this solution, we brought these three. In our documentation, this is the tetsoft.com/ml. This is a page we did for this conference here specifically. And if you scroll down a little bit here, you'll see that we have the technical resources when it says ml.net example. So let's open this one here. And you can see that there's the explanation of the solution here. You can download all the files necessary here. And this solution was done based on the four pillars methodology. When you first define the data foundation, then the industrial operation, then the business operation, and also the user interaction, which is the display. You can have a look here. You can already download in the latest version we have available. And yeah. So the next thing I wanted to show is, okay, based on the same example I just showed you, this trend shows the data we had to train the model. This is simulated data, but it works the same with real data. We expect to have as many data as we can So, and every time you have more data, your model gets better. In this case, we had like temperature, pressure, all these variables here for the anomaly detection algorithm. And when it's in runtime, we will have all these variables that are not circled being collected from the field, and then we predict what is the is abnormal state, and then it will say to you, okay, this is normal, this is abnormal, and also the score would be as much higher it is, it's closest to the abnormal. And then, okay, so how do we do that? It seems to be very complicated, but it's actually not using the ML.NET from Microsoft. The only thing you have to do is call a couple methods, and here it represents what you have to do. So the first thing is to load your data. So let's say that you have a machine, you collect the data from that machine, and then you have 6 months of data from that. Then the second thing, you create the input and output classes. It means every machine learning model, you have the inputs, which are the process variables usually, and then the output is the result of that machine learning model, depending on which algorithm you're using. The third thing would be to build the pipeline. This is you say to the machine learning what you want to do, what specific algorithm you want to use. And then when you have all of this defined, you train the model. The next step is to evaluate the model, where you get a subset of data from that, and then you try to run the model inside of that the same some set of data that you had at the beginning, so you know if your model is good or not. Then you just save this model and you use that with the new data that is being collected from the field. And in this case, we are talking about predictive maintenance. So this is what we want to achieve because it's fixed based on the actual condition and predictions. You don't have to have fixed schedules, or at least you minimize that. And you also don't have to fix when it breaks because the cost will be much more. So the good thing about having the predictive maintenance is that you optimize your cost and you minimal downtime. But the bad part is that you require data, sensors, and analytics. And here is where that software frameworks is to help. Here, let's go just for a practical example. So we have a tablet compression machine from pharmaceutical vertical. And the first thing we'll do to implement machine learning model in this machine will be to collect healthy data. So let's say that you have your machine operating in good behavior. It's a new machine or it's working very well. And then you collect 3 months or 6 months, as much as you can of data of that. Then the second step will be to train an anomaly detection model. And this model will understand what's the normal state of that machine. The third thing would be to monitor live machine data. So you will be collecting through sensors data from that machine, let's say temperature, pressure, uh, any process variable. And then when you input this in the machine learning model, the output will say, okay, this is a normal operation or it's not. And if it's not, in frameworks, you can set an alarm so it will tell the operator that it's not good, so he can schedule maintenance or see what's the best approach for that specifically one. Okay. Let's go to Visual Studio. These next 5 to 10 minutes will be a little bit more technical, but it's still easy to understand because ML.NET is helping us a lot. So you remember all the 7 steps I mentioned? For each one, basically, you have just to call one method. And who is familiar with programming will understand that it's very easy to call a method, just like we did here. So the first step would be to load the data that we want to train. So we just put a CSV, it could be coming from any database. Then we will train a model. So if you go here inside of this method, you build a pipeline just like we talked. You can define what's the algorithm specifically inside of regression. Okay, so here we are in the Visual Studio for Microsoft environment. Okay, this is not frameworks yet. And in this example specifically, we are using the regression, but it works the same with almost all of them. It's just a couple things that modifies, but any LLM can help you a lot to understand this process. So, okay, just keep going here. For training the model, we are using regression, just like it says here. Inside of regression, you can have many more algorithms. So you can see here that we have fast tree, you can have light GBM, and you have a couple more. This is what ML.NET delivers to you. But in this case, we are using the light GBM. So we build a pipeline. This is what we need to do to build a pipeline. This is basically one line. And then we train the model, just calling one method. Very simple. Okay, now we already have the pipeline and we have the training model. The next step would be to validate the model. So if we go inside here of the method, you can see that we just transform, evaluate, and this evaluate comes from the ML context, which is, if we go in the ML context, you can see that it's part of the Microsoft.ml.ml context. So this is the library from Microsoft for that. And then that's all. You already evaluate. You have some metrics here that will be different for each algorithm, but it can indicate like if it's closer to one, it's because it was a good trained model. And then now all we have to do is to save the model. So we have another method for that. It's just also from the ML context, and you call the save method. It's pretty easy. And then now we load the model. And at this point, we already have the trainer model, and the only thing we need to do is to use this. So in this example, we input the temperature and the pressure of these values here, and we preview what will be the quality. And then we have the result of the quality here. So this is the whole process of training and using a machine learning model. And we can also see that in frameworks. In this specifically case, we train the model outside of frameworks, and the only thing we'll do is these last lines here. So we will load the model, give the inputs, and these inputs will come from the field in real time because you are reading data from, let's say, ControlLogic's PLC. So when you input this data and then you do a preview to that, you see what is the predicted quality. Okay, so here we are in the Visual Studio environment, and now let's go to the frameworks environment. If I open here our designer, and the machine learning models are done in scripts. This is the same example I show you in the documentation that you also can download. So let's go to scripts, classes, and let's select regression. So you can see that it's very similar to what I show you in the Visual Studio environment. You can load the model just like we did. You can have the inputs, and these inputs can come from tags that are reading values from the field. This is actually what we are doing here. The only thing that we don't have the direct tag here because we are calling a method, so it's passing as a parameter, but it can be the directly value you are reading from the field. And then you do a preview on that. And then you have the result, which is the quality index previewed. You have to define a couple more things here, like the inputs and outputs classes, just like we did to the Visual Studio, but it's pretty straightforward. ChatGPT can help you a lot with that. And then you have some methods, but it's just like two rows each one. And you also have the fields, which are the verbal declarations. But okay, once you preview this value here, you can have that in a tag in frameworks, and then you can display on the screen. You can do analytics with that. So this is what we did here in the example I show you. We input the pressure and temperature in real time, and then with the machine learning model, we predict the quality. Okay, if you have, this is what I have for ML.NET. If you have any questions, just drop in the chat, please. I'm going to finish my explanation by going to the MCP. So let's go back to our website here. So if you scroll down a little bit, in the same place we got the last one, you see that we have the AI MCP tool connector. Just open this tab here. And I'm starting by explaining what is the MCP and what you can do with your application. So this is a different subject. It's not machine learning anymore. Okay. This is called MCP. So think that in one side we have frameworks collecting data from the field. So you have that data in tags, you have historic values from those tags, and you have alarms being triggered. You can also have custom methods that you do by your own. But okay, let's say that this is a bunch of data, a lot of information. And then in the other side, you have LLMs like Claude and ChatGPT that you want to access values from your frameworks application. With this kind of new technology called MCP protocol, it's possible because you have some bridge between the two, and then we can talk to each other. So in frameworks, we have our built-in MCP server that will be in between them, and it communicates using the MC protocol. What it makes possible is to, let's say that you have your Cloud AI there, and then you want to ask, okay, what's the temperature of the brew house at this time, the current value? You can ask to ChatGPT that or to Cloud AI, and it will retrieve information from your framework application. So let's go to the real example. So here I have Cloud AI in my browser, and I have a chat that I did a couple weeks ago that can show how powerful that technology is. So here we start by asking what's the server system monitoring uptime of some specific solution. Let's say that I have a solution just like I have here. I had one called Bowling Line MCP demo. And what we do is to query that value from our MCP server. So it will consult our frameworks application. What's the value? And it's exactly what was done here. It queries this specific property using the get value, and it retrieves us the information. So 13 minutes, timestamp, current timestamp, and you can query any value. It could be a temperature, it could be a pressure, any tag that you have in your solution. Then you can also ask information about alarms. So here I ask, is there any active alarm or has there been one recently? What we do is to query and frameworks returns all the information from the alarms. You can see here. And from this data here, Cloud AI can format this data in an easy way for a human being understand. So we have 8 active alarms, and then it says that we have 5 that are not normalized yet, and we have 3 that were already normalized. So it says the current value, it says the alarm limit for each one, and active since when. And then every time you can check that again, and it will get from the current value. In this case, we had 4 acknowledged and like 2 more that are already acknowledged again. So it says all the information about the alarms you have right now. And you can ask questions. Once Cloud AI already have the information, it can format and answer whatever you need. Okay, so I talked about getting data from tags, about alarms, and one thing we can also do is to retrieve historical information from those tags. And that's what we did here. So we asked to retrieve the historical values of brewery, brew house temperature. And what it does is to ask for a specific time range that you can also define for a specific tag, and it will retrieve you all the information about that tag specifically for the historical values. So you have the timestamp, the value and the quality that tag was at that time. You can see that we have a lot of data here. And it also gives you a summary of what that is. And one thing very interesting is that in this question specifically, we didn't ask anything about alarms. And it got from the past conversation, we had the past questions, that the alarm threshold for that specifically tag is 35 degrees. So Claude is always looking for what you asked previously to give you the best answer currently. And you also can ask to plot a trend visualization for the data. So it can take a couple seconds. So I already did that. And here you can see that it plots the trend visualization. And it's also interactive. If you have that in Cloud, you can pass your mouse, your cursor over it, and it will say what's the temperature in this point here. In this specific case, we asked for the last 5 minutes. And then you can have a beautiful trend visualization here. You can also ask to refresh this trend, so you can see that it added 11 new lines and removed 17. You can also ask what's the highest value that this tag had, and it say to you and also say the timestamp. And one interesting thing is that first we talked about ML.NET, and now we are talking about a different technology called MCP, but you can also use both together. In this example here, we are running anomaly detection for a bottling line in FrameworX, and we had these anomalies detected. So it says the timestamp is this one, the value is this one, the score is this one, and you can query those results from machine learning using MCP by doing a custom method. So in frameworks, we have a documentation that I show you that you can do your own methods because getting tag values, alarms, and historian values are already embedded in the system. But you can also do your own. So you create a method there that I will show you, and you are ready to do your custom one. So yeah, this is the conversation we had to Cloud to show how powerful that is. And let me finally show you the documentation. So this is a tutorial of how to implement MCP. You can scroll down a little bit and you see that we have some steps here. It's all described and it shows that you can do your custom method. So basically you give it a description of what the user should ask to retrieve this specific method. You can pass some parameters here, and then you can do any logic you want inside of here and then retrieve this information to the Cloud AI. Yeah. Let me see. Yeah, I think that's all I had, Isabella. Thank you.
Thank you. I appreciate it. When we think AI, there's a lot of different names and new technologies. So I asked Eduardo to show really ML.NET and MCP and how to use them together. So just so you can see, really, there are different ways of using AI into those projects. And we can help you with that. Feel free to leave questions on chat. I'll do a small wrap up just for us to kind of like think a little bit about everything we just did. And then we'll go back. I'll answer any questions you guys have. So I think first thing, it's important when thinking about AI to kind of start small. It isn't the instinct to kind of try to solve everything, but it's important to kind of pick one asset or process and one clear question that you want to answer and start from there. If you're thinking of implementing machine learning, anomaly detection is often the best first step. It is one of the easiest to kind of incorporate cleanly with existing systems. And once you do that, you can definitely expand and more signals, tunings, different kinds of codes and things like that. And the most important thing to kind of remember is that ML improves greatly through feedback and retraining. So this is not something you're going to do once and never think about again. This is something that you need to be working on constantly. I think all of the kind of key to highlight that is when you look at the code and it's like, oh, there's a lot of it, but that's not the hardest part at all. The hardest part is actually the data that comes before it. You want to have quality, you want to have consistency, and you want to have context. And that's really where a unifying platform like FrameworX really helps because data is already contextualized, historized, and accessible, which really reduces the friction when introducing machine learning. Oh, sorry. So yeah, if you get one thing from this presentation today is that machine learning really works best when it's part of a system, not a separate experiment, but something that's incorporated into the everyday stuff. So start small, retrain your models, but let the platform do the heavy lifting. So yeah, we'll open up things for questions now. Thank you guys once again. I appreciate your time and the presentation. I already see Paulo is asking something here on chat, so we can start with that, which is, can one define and utilize several databases at the same time? For example, search a sales database for the to-do orders and the FX database for the real production data, and does it determine the best temperature and pressure for each other?
Okay, I think I will divide that answer in two parts.
Yeah,
The first one would be the machine learning part, which, okay, so let's say that you have these two tables. You cannot just say, okay, understand what that is. You have to define and organize this data to give to the machine learning to learn in a way that it will understand. It always depends on the task you do, let's say regression or anomaly detection. But once you organize that in a way that you can train the machine learning model, and one thing that can help you a lot is ChatGPT and Cloud AI. I think both are very technical and can understand the ML.NET because that's a library and that's public, so it can understand that. You can train the model in that way. But if you are now the second part is that if you are asking about MCP, you can create a custom method, just like I show you, that can retrieve the information from that database that you want. And then Cloud AI may understand that. We can never assure you that Cloud AI will understand and give you a correct answer that's intrinsic in the model of LLMs, but it usually is very good in doing that, in understanding multiple variables. So in summary, yes, but you have to organize the data and make available to the LLM to understand that.
perfect. And I think that's the key part of it. Every time you gotta be the one thinking about the data, organizing it. Otherwise, the tools are not going to do their job.
Yeah,
Um,
it's just like the LLMs. You
yeah,
cannot make a general question. You have to be specific in what you want, and you have to understand how the LLM will deal with that.
perfect. Dave, I think it's worth mentioning a little bit about the licensing and how it works because we introduced all those tools. And I think one thing that it's important to make clear for those who don't know is that we are a complete tool. So this is not an add-on, this is not something extra. So do you want to talk us a little bit through like our different product family and because all of them include this?
Sure, absolutely. And that's a very important point is that all of our configuration tools come with every license that you get. So large or small, you've got all the tools included. Um, so we really have three different license types that we provide. We have our enterprise level licensing, which we have our unlimited. So FrameworX Unlimited, which is again all the unlimited configuration tools completely enabled. Unlimited IO, unlimited runtime users, and unlimited simultaneous development engineers working together either on the same project or even on separate projects through a common server. So that's the enterprise. We sell the Enterprise Unlimited at $11,900. So that's the max you'll pay for an unlimited license with us. And then we have some smaller sizes because as good a price as that might be, sometimes you only have a 1,500 point need, or sometimes even smaller than that. Maybe you're building an HMI and you only need, up to 150 or 500 IO points. So we have smaller size licenses. So we have what we call FrameworX machine HMI that goes from 150 IO points to 500 and then 1,000 IO points. At the 150 IO point size, you're looking at $900. At the 1,000 point size, you're getting that's at $3,200, but that's for 5 simultaneous users.
Nice.
Okay, so it's not just a single person running on a standalone. You can have 5 people running that application off of that server. So the pricing for the enterprise and for the machine HMI we feel are very competitive, especially given you get all the configuration tools. And then we have another level of license called the Edge Connect, which again includes all the configuration tools, but it doesn't provide for visualization, for alarming, things like that. It's more about migrating your data, managing your workflow. So it's got over 100 connectors for devices, drivers, if you will, to controllers and such, includes Rockwell, Siemens, Modicon, Mitsubishi, OPC. It includes an MQTT broker, a client, and a Sparkplug B client, all included. So it's all about the connectivity. So connect to the data where it lives and then move it somewhere.
Yeah.
So it's all the connectivity to databases and historians, things like that. And it includes store and forward capabilities. So if you lose that connection out at the edge, we'll buffer the data up there. And when that connection is restored, everything gets forwarded on. And it also includes the C# and Python scripting as well. So you can, whatever sort of business rules or algorithms, things like that you want to impose on the data, do all that before it gets slogged. All that's included, unlimited capacity. So connect to as much IO as you want, connect to the databases. We sell that for $750, like hotcakes, by the way. So that's our 3 levels of licensing: the Edge Connect, the machine HMI, and then the enterprise versions of FrameworX.
Awesome. Appreciate that, Dave. I think it's worth highlighting that. Eduardo, Paulo corrected himself, and that actually matches one question that I got here on Q&A. So he said that his question had more to do with authorization to access external database records and the protection the database owner can expect. And I actually got a question here about how the security and permissions really apply to all of this. So can you give us an overview?
Sure. So if you are training a model outside of frameworks, and this is an external database just like SQL Server or Postgres, the same rules that applies to C# will apply to this. So that's pure C#. When you do inside of frameworks, you can have database connections. So the security will have the same that we have in framework. So you can define the username, the password, and what you have to do is to call a method that will query the data from that external database. And the database we support are all that framework supports. So let's say SQL Server, Postgres, SQLite. So yeah, I think that's the answer for external databases.
Perfect. Paulo, let me know if that did not answer your question. Eduardo, I don't know if you can actually see if you click Q&A at the bottom. I will read through to you the question, but also I think it's worth reading if you need, which is Sam asked, we need a high operating speed for the image processing and analysis system we've set up for quality control on our production line. Will the speed be affected when the data size increases?
So Okay, let me just explain one thing before.
Yep.
When we run a process like we did in the scripting frameworks, you can run in different threads of what the system is actually running. So every time you create a new task, you're running a different thread in the machine. So your processing will always depend on the memory and the processing power of your computer, and it will not affect frameworks. If the data size increase, your model will be bigger, and it can slow down the real-time analysis, but this is something you will need to test to see until what point you can do. It has the same, it doesn't have to do with framework specifically, because this is C Sharp, and it will have the same behavior as C Sharp does and .NET.
Perfect. But I
And
think Scott,
there are probably other things we can do as well on the operational side, setting up the communications, having multiple threads to controllers and things like that to help even the overall performance of the system. So there's a lot of ways to optimize within frameworks.
Yes.
beautiful. And I think Scott highlighted that C sharp is pretty good on performance in general. But Eduardo's right, it depends. Awesome. See if I have any more questions here. Dun-dun-dun. Part of the machine. I don't think we have anything else on chat. I'll let you guys have another minute, but let me make a note here. This page that Eduardo shows that has all the technical resources. I'll be adding the recording for this presentation, and I'll share with you all. You're gonna find there all the links he mentioned. You can download the demo we showed, a little bit more information about our tools, and most importantly, you can download software right now and start testing it out. Add your own models, play around with your own data. Everything out is explained on the website. I'll be sending that out later today, probably. And you can get that started. I think we're good at this point. First, I'd like to thank you, all of you, for being here today, and anybody who watched as well. Anything else that you guys would like to highlight as a last thought before I officially close it? If not, I think it's just kind of highlighting that again, that AI is a new tool. There's a lot of stuff that's going to be showing up soon, and we are keeping an eye on it. But at least those new technologies that we're already talking about, ML.NET and MCP especially, I think can really take your process and your operations to the next level, really help you. We can help you to get started. Talk to us, schedule time with one of our engineers. When it comes to technical, I find that it's better to talk with people and really explain what you need, and we'll go from there. So yeah, I will send you everybody's, Dave, Scott, and Eduardo's information as well, so you guys can talk to them, and we can get this conversation started. So thank you so much for being here, guys. We'll talk to you soon. Keep an eye on our socials. And yeah, have a good day.
Thank you.
Bye.